Welcome to unit testing in ASP.NET Core WebAPI video series. Today is the third session, and today we are going to discuss how to unit test the service layer in our ASP.NET Core WebAPI project. So typically when we develop any ASP.NET Core WebAPI project, architecture is basically organized into three primary layers. What are these three layers? Let us try to understand. One is the presentation layer. So the presentation layer is nothing but you can consider the controller, whatever we created in our project, they are going to be the presentation layer. So basically, they are going to handle the incoming HTTP request. They are going to do the primary validations. They are going to return the data, the right client. So basically, the HTTP related concerns like routing, status code, response formatting, these are the things is going to be handled by the presentation layer. The second one is the business logic layer. So in our ASP.NET Core WebAPI project, typically we are going to create services. The services is going to sit between the controller and the data access layer. So it is the main component you can also consider where the core business logic is going to be reset. So here we will write the business logic, we will write the transactional statement, right? All these things are going to be managed within the services. And the last one is going to be the data access layer. So typically you can consider the repositories, the DP context are nothing but your data access layer. So as part of the data access layer, our main and only responsibility is to deal with the database. So how to perform the database CRUD operation, that is going to be managed by the data access layer. So in this session, what we are going to discuss, we are going to discuss how we can effectively unit test the services. And in our next session, we'll discuss how to unit test controller and data access layer. So before going and understanding how to write unit test for the service layer, first of all, we need to understand what are the role and responsibility of service layer. Why do we need to perform unit testing for the service layer? What are the different approaches to implement unit testing for the service layer components? All these things we are going to discuss one by one. Let us try to understand what is the service layer content. If you look at this example, or you can say here, the controller is there, which is going to handle the incoming HTTP request. Then the controller will forward that request to the service layer. So this service layer, what we are going to discuss in today. So its main responsibility to manage multiple repositories. For example, if you want to place an order, for placing an order, the service layer going to deal with the order repository, going to deal with the product repository, going to deal with the customer repository. That means it is the right, that means the service layer is going to manage multiple repositories to perform the operation. The second one you can consider enforcing business rules. So for right, while placing the order, whatever the business rules you need to check or you need to apply, like the stock validation, like the discount application, like the tax amount generation, shipping charges applicable. So whatever all your business logic, those logics are also going to be reside in the service layer. Again, handling the transaction. So handling the transaction means what? Like, see, in this case, as you can see, we are going to perform different kind of operation on different database table. So we are going to create an entry in the order table, going to manage multiple entries in the order items table. We are going to validate the product. I mean, updating the stock quantity in the products table, checking whether the customer exists in the customer table. That means we are performing different operations on different database table. So one of the fundamental role of database operation is automation. Automation means either all operations should completed successfully or none of them, but it should not be in some kind of a partial update. So that's what you can manage using transactions. The service layer is also responsible for managing transactions. So these are the role and responsibility of service layer in a typical ASP.NET Core Web API applications. Now, so what is next we are going to discuss? We are going to understand why unit testing the service layer is very important in our application development. So let us try to understand. So basically I have pointed out four important points. Central logic location. So service layer is the component where the business rules and the logics are going to be implemented. So most of the time, right, whether your business logic are in right working as expected or not, for that purpose we need to write unit test for the service layer component. Early bug detection. Guys, remember, most of the time, right, most of the time, whenever we are facing some issues or if the function application is not working as expected, it is only because of the service layer. I'm not saying only, But 99% of time, it is only because of the service layer component. Why? Because we are not going, controller is nothing. Inside controller, what is that? Only receiving the request, handling the calling the service class method. Nothing else. Whatever the service class method, that what the controller will return to the client. And what is there in the repository? Only the database CRUD operation. So we will rarely face any kind of issues in the controller class and is the repository class. Most of the time, it is the service layer. So early bug detection is always better. So as soon as you write the unit test and you test the service logic, and if you see that the issue, the application is not working because of the service layer, so you can easily fix and give a so basically you can easily fix the issue in the service layer, and most of the time, the issue is related to the service layer. Isolation testing. So, guys, remember, whenever you are performing the unit testing, it should be an isolation. So, testing the service layer means we should use mock object, right? It should not have any dependency on the repository object, repository class, or it should not have any dependency on external API. It should not have any dependency on database. So, it should create a mock object and test the service layer logic so that we can give guarantee that the issue is related to the service layer, not related to the external dependencies, and facilitate easy refactoring. Guys, remember, today you develop the service method which is working as expected, but tomorrow the client complain that this method is taking more time. So giving the response rate, it is taking more time, like 5 seconds, 6 seconds. So now it is your responsibility to refactor the logic, right? See, guys, remember the response what you are sending is correct, but it is taking more time. That means you have to figure out why it is taking more time, and at the same time, you have to make it perform faster. That means you are going to refactor the code. But at the same time, once you refactor the code, again that unit test code, whatever you have written, that you need to check whether that the main application logic is working or not. So that means it will that unit testing is facilitate easy refactoring. So these are the reasons why you should perform unit testing the service layer component. Now, so as I have discussed, while performing the unit testing, right, whether it is controller, whether it is service, or whether it is repository, that unit test should perform in isolation. Means what? There should not be any dependency object. For example, if I'm going to perform the service layer unit testing, service layer is depending on repository layer. Why? Because to perform the database operation, either for getting or retrieving the data or updating, delete, inserting. But in case of unit testing, it should not use the database or the real implementation. So what we need to do, we need to create a mock object. You know, what are the mock object? Mocks are nothing but the fake object that implement the same interface as a real dependencies, but behave in a control and predictable manner. Right? For example, if there is a product repository, so then what you need to do, you need to create a mock product repository. This mock product repository implement the same interface, that is I product repository, whatever the interface, that the interface is going to be implemented by the mock repository. Your actual product implementation is going to deal with the database, but this mock repository is not going to interact with the database. And within the mock repository, you can define when one method is called what to return. That is return predefined data, and sometimes you can decide, right, if this is the input, then I need to throw that exception. So anything, whatever you want to return, that what you can return. So this is the use of a mock object, and this mock object is very, very important whenever you are performing unit testing. So what are the different approaches to create the mock object? So mainly there are two approaches. One, you can use in-memory database. So instead of using the actual database, what you need to do, you need to create one in-memory database which is supported by entity framework code. And another one or another approach is to use the mocking framework, and mostly we are going to use mock framework. So let us try to understand what we mean by this in-memory database. So in-memory database means you have to create a in-memory entity framework code in-memory database provider. That means you have to use entity framework code in-memory database provider, create one in-memory database, and this in-memory database uses actual repository implementation, provides you right the option, or you can say it provides us the flexibility to test the queries in the same manner as our actual database, but with some limitation. What are the limitations? Within memory database, you cannot apply constraint, you cannot apply indexes which are applicable at the database level. So this approach is closer to production behavior, may still differ in some specific feature and constant. So what exactly means? It means if your actual database is SQL Server, then whatever the feature and rate constant, whatever available with SQL Server, you might not get all the features with your in-memory database. The second option is a mocking, using a mocking framework. So this mocking framework create a mock object or mock repository, and this mocking framework will provide the full support for complete isolation. It simplifies the testing scenarios, timeout scenarios, exception scenarios, which are difficult to achieve using the in-memory approach. And this mocking framework is going to run faster than the in-memory approach. So most of the time in your application, you need to use this mocking framework over this in-memory database. But yes, this is also possible. So what I'm going to do is, first of all, I'm going to show you how to use in-memory, and then I'm going to show you how to use mocking framework. And for in-memory database, you have to install this package, and for mocking, you need to install this package. Let us proceed and install these two packages first. So this is the project which we have already created in our last session. This is my API project and this is my text project. So in the text project, what we need to do, we need to install this package, right? So how you can do this? So open package manager console, then write this command and select the text project. So once you select the text project, click on the entry button. So this should create the this would install the package. The second package we need to install is this one, which is going to be our second approach to create the mock object. So once this is done, next what we need to do, we need to create the service. So we need to create the order service unit test class. And this order service unit test class initially going to make use of this in-memory database and trying to perform the unit test. So let us proceed and understand these things. So first of all, let me create a class. First of all, let me create a services folder. Guys, remember in my test project or whatever component you are going to test. For example, I'm going to test the services. So you have to create a folder called services. Similarly, whenever I'm going to unit test the controller component, I will create a folder controller. Similarly, whenever I'm going to unit test the repositories, I will create a folder called repositories. So that's what industry standard, that what we need to follow. So once you have created the services folder, then create a class file. So this class file rent is nothing but our unit test. So basically, whatever your component order service. So basically, if you look at the services folder, I'm having this order service class. So this order service class, I want to unit test. So this is my order service class. You can see it is dealing with multiple repositories, performing the database operation, applying the validation. All these things are there, which we have already discussed in our last session. So I'm not giving focus on this one. So this is my order service unit test class. So now let me make the class ready to use in-memory object, in-memory database. So how we can do this? Let us try to observe. So this is my class and this is my private method, build context and services. So basically whenever I'm going to unit test, each time I need a context object and I need the service instance. So without the service instance, I cannot invoke, right? For example, without this order service instance, I cannot invoke this create order method and this get order by IT method. So these two things is required. And again, if you look at this, right, for this order service, I also need these repositories. So let us proceed and see how we can do this with our unit test. So first of all, what I need to do is, so before repository, if you look at the repositories, for example, this order repository. So it is dealing with the DB context. And this DB context word, if you go to the application DB context, so it is going to deal with our actual database. So this actual database, what we created in our database, right? What is the database? Order management DB. When I forgot, let me go ahead and check. So this is going to be orders DB. So this is the database. So I'm not going to use this database. I want to use a mock database. So how I can do this thing? So let us understand. So first of all, you have to create one DB context option object. Here you want to specify what mock object you want to create. I mean, what is your actual DB context object for which you want to create a mock object. So in my case, my actual DB context is application DB context, which I have created here. So for this application DB context, I want to create the mock object. So that class name you have to provide here. And what should be your right database name? Order service test DB, and each time right I call this method, it should generate a new in-memory database. So to make each service method, right, for each service method a unique database. So what I'm doing, I'm appending this GUID, which will definitely give us a unique database. And in this case, right, and the in-memory database having some limitations. What are the limitations? The limitation is you cannot apply constant, you cannot apply transaction management. So that's what we want to configure, that we are not going to deal with the transaction management. So once you create the DB context option, then what you need to do, you need to call the application DB context class. So here you can see that application DB context class expecting one option object. Now that option object here we are passing. So, and we are telling that we are going to deal with this database rather than the configuration what we provided here, right, is not going to be, it will not come into the picture because this is what we are manually setting. And then we are creating the DB context. So once the DB context is created, then you can specify what are the dummy data or initial seed data you want to store. I want to store these two product information, ID1 and product ID2. I want to add a dummy customer, or that is the customer ID1, calling the set changes method. So at this time, so what will happen? Now it will create the database, and the database name is going to be this one underscore GUID. And within this database, right, it is going to store the products table with two entries and the customers table with one entry, right? So this DB context is done, but once the DB context is there, if you look at the order service, to create an order service instance, what you need? We need the product repository instance, we need the order repository instance, we need the customer repository instance. Now, if you look at the product repository, so to create the instance, we need the application DB context. Similarly, for order repository, we need the application DB context, and same for the customer repository. So what we need to do here? Now, do we have the DB context object? Yes, we have the DB context object. Then can I create my repository instance? Yes, you can create. How? Now call the order repository by passing the DB context, call the product repository, and same in the case of a customer. So here we are having the repository instance. So once we have this three repository instance, then can I create an instance of order service? Yes, the constructor expecting three parameters. One is for order repository, product repository, customer repository, and that's what I'm doing here. I'm passing the order repository, product repository, customer repository, which is going to return me the order service, and the DB context instance, this DB context instance, and the service instance, that what I'm returning from this private method. So this private method is going to be invoked from each service or from each unit test method. And this private method is going to set the DB context, that is the in-memory database, going to create the instance of repositories, going to create the instance of a service class, and it will then return the DB context instance and the service class instance, so that inside that unit test method, you can consume the services. Okay. So let us proceed and write some unit tests so that you will get some better clarity. So let us start with this unit test for successful order creation. So basically what we need to do, we need to set up the in-memory database and service. We need to create a valid order. Valid order means valid customer, valid stock, valid product, and check that order, and then check whether the order is created as expected or not. In this case, we are going to use the product 1, quantity 2, product 2, quantity 1. The total base price is equals to this one, which is below 500. So the discount should be 0. So let us proceed and create this unit test. So just below the private method, so call this one. So here you can see this method is what I have created. First of all, arrange. So as I have already told you, there are three actions. One is arrange, add, and action. Arrange means make the database ready. make the context object made ready, or you can say make the dependency object ready, as well as make the data ready. So here my dependency object is ready. So whatever the DP context order service, I call this private method, and that's ready. So once this is ready, then whatever the data I want to pass to create the order, that what I need to create. So here I'm creating a valid order DTO, passing the customer ID, list of order items. So I'm passing two order items here. And then once you have this order service, you can call this create order method by passing this valid order DTO. So whatever the DTO I'm passing, so this will return me the order response. First of all, the order response should not be null. So here why I'm saying, because this is a valid TTO. Valid TTO means what? The order should be created. If you are getting null, means there is some issue in the create order method. So if it return not null, means order is passed. Then that return detail should have the customer ID one. So here I'm passing the customer ID one, and as a response, I also expect the customer ID to be one. So in this case, I'm passing the list of order item as two. So in the same time, whatever the order response I'm receiving, it should return me the count as a two. If not returning, means there is some issue in the create order method. Then what is the expected base price? So expected base price means what you can see. I have set the product to one price is 100, product two price is 200. That what I have calculated. This is my expected base price. So this expected base price and whatever the order response the base amount, they must be equal. Similarly, whatever the discount, as in this case, the total amount is less than 5,000. So the discount is going to be zero. And the total amount is nothing but, right? So the discount is going to be zero. And total amount is nothing but your base amount minus a discount. And in this case, it is going to be same 400. And then what I need to do after this one, I need to check whether the product is created or not. So by right using this find one async method, right? I mean, right, once this operation is completed, right, currently, if you look at this product one stock is 5. And here, how many quantity we have purchased two? So after the order creation, right, if the order created successfully, then this stock quantity should be reduced by two. Means what? Now the available stock should be three. Similarly, the first product ID two, the stock quantity available is two, and here we are purchasing one, so it should update it to one. So that's what we are checking here. So using the DP context, I'm accessing the products with the ID one, and here I'm expecting the stock quantity to 3, and for product ID 1, the expected stock quantity is going to be 1. So let us proceed and test this rate service and see whether it is working as expected or not. So go to the text explorer, expand this, and test this one. So it is still running on. Yes, the test succeeded. That means that the functionality is working as expected. That is successful order creation is working. Now, right, guys, remember whenever you are going to write unit test, so this is my order service method. Don't think that I only want to write a single method, single unit test method to check the functionality. No. So unit testing means all the positive as well as the negative scenarios you need to check. For example, this is one valid scenario we have tested. Now we'll proceed and create some invalid scenario. So some invalid scenario means a product not found. So basically, I'm going to create one order and I'm passing the product ID which is not exist in the database. For example, here you can see in the database I'm having only two products, one with the ID one and a two. And here I'm creating a order with the product ID 999. So is this product ID available in the database, in the in-memory database? No. If it is not available, then while I'm creating the right, what I can say order service, it should throw me an exception. What exception it should throw? If the product is not available, it should throw me not found exception. And if it is throwing not found exception, that means the test is valid. Otherwise, we need to check why it is not throwing the exception, right? So let me run the application and test this feature. So this text, this one I need to test. Right click and click on the run button. So this should test, and you can see test is passed. That means this functionality is also working. Now we need to check insufficient stock. I mean, I want to place one order with the product ID, and whatever the stock I'm sending and whatever the available stock, that is not valid. For example, for the product ID one, how many stocks are available? Stock available is five. Guys, remember, each time it is going to create a database. So don't think that one operation is completed, it is going to update the data. No, for each unit test method, this logic is going to execute and it will generate a new database. So in this case, you can see for the product ID 9, not this one. So insufficient stock. So here I'm passing a valid product ID, but quantity I'm passing as 10. At the same time, that available quantity is going to be 5. So let us proceed and run and see whether it is throwing the invalid exception or not. So right click, text explorer, and this method, right click and click on the run button. So here you can see it is completed successfully. So test succeed. So next what I need to do, unit testing for fetching an existing order. So for example, right, right, for this purpose, right, you can see in the order service method, not only this create method is there, but also this get order by ID method is also there, which is going to return me an existing order. So how to test whether it is returning the order as expected or not? So for that purpose, I'm creating this one. So first of all, what I will do, I will create a valid order and then I will access that order, because each time we run, it will create a brand new database in memory database. So there should not be any existing order. First of all, I will create one order, then I will retrieve that order and I will validate whether it is retrieving the same order or not. So this is my create order. So customer ID one and one product is there. Calling this method should create the order. So here I'm checking whether order is created. It should not be not null. And here, what is the order ID from this created order? That's what I retrieve. So then once I retrieve the order, then I'm calling the order service get by order ID method. So this should return me the fetched order. So and definitely it should write whatever the order ID created, that order I'm passing means it should return me the data. If it is not returning the data, means you need to check why it is not written and why I mean there is some issue in the application logic. So now whatever the fetched order, it should not be not null, and whatever the order ID we have extracted and this fetch order ID, they must be same. Whatever the customer ID, so here we know that the customer ID is going to be one, so that the fetched order customer ID should also one. And in this case, it should have a single item because only one item I have provided. So accept the single is going to ensure this items collection contains a single element, right? So now let me go ahead and test this functionality. And this time also it is going to be succeeded, right? So you can see this is working as expected. Now, so now what I need to do, I need to check one non-existing order. Non-existing order means I will create one test method and I will check whether that order, going to check the invalid scenario. See, in this case, I'm creating the DB context and order service instance. And here I'm simply calling this method. So one brand new database is going to be created. There is no order, and here I'm trying to retrieve a order. So that definitely this order not exist in the database. So if it not exist, then it should return null. And here that is what I'm checking. If it return null, means our application is working as expected. So let me go ahead and test this functionality. Okay, see, again, it is working as expected. So this is nothing but, in this case, creating an in-memory database. So whether, right, as you can see, it is creating one in-memory database, but the logic, right, the repository, it is using the actual repository. So whatever the code we have written here, whatever the code we have written here, whatever the code we have written here, these code are going to be executed. So creating in-memory database and using the original repository is not the ideal scenario for testing the service class, right? So what is the best solution? Best solution is to use the mock object, right? Using the mock framework. Why? Because mock framework is lightweight. It will use fluent expression. I mean, using the dot operator, you can use multiple method, and it also support the asynchronous support, right? You can return the data in asynchronous manner, It is well documented means currently .NET provides support for this one. So let us proceed and understand how to write a unit test using the mock framework. We have already installed the package, mock package we have already installed. So let's go ahead and create a class file. So this time what I'm going to do is I'm not going to write all the unit test one by one like the way we have created with this order service unit test. So I will write all the unit test and I will show you at once. So now right click and add a class file. So order unit test with mock. I'm giving a different name so that you can understand. So this is using in memory and this is using mock object. So let me proceed and create this thing. So this is the recommended approach by using the mock object, how you can perform the unit testing. So let me copy the code and then I will explain each and every statement line by line. See, first of all, I'm not going to use any in-memory database. Second, I'm not going to use the actual product repository implementation. See, that means what? Now we have to write the code where the application DB context should not be there, where the repository implementations like this product repository, order repository, and customer repository should not be there. Then how the order service is going to execute it? Now for this purpose, I will create a mock order repository. I will create a mock product repository. I will create a mock customer repository. And while I'm creating the mock order repository, so if you look at this method here, I'm having three methods. So I need to tell, right, when this method is being invoked on the mock order repository, what data to be written. I need to tell when this add async method is going to be called and what needs to be done. That means the implementation, what to return, how to return, is going to be defined by the mock repository class. And how to create the mock repository instance, first of all, using the mock object. So using this mock generic type, you can define the variable. So here you can see I defined mock order repository, mock product repository, mock customer repository. So this interface, first of all, I declare few variable and I want to return the order service instance. That is the reason why I also create one variable for order service. See, whenever I'm going with the order service, I'm not going to create a mock order service. So this actual logic I want to execute. For executing this logic, whatever the dependency object. So in this case, these three are nothing but your dependency object. So this dependency object means we need to create a mock for this. So this three variable what I created is nothing but creating the dependency object mock object. So creating mock order, product, and a customer. So how to create the instance? See, using the same new mock, I'm creating the instance. So in this case, this mock order repository will implement the I order repository. So implementing means providing implementation for this three method. And this means what? Like it is not providing implementation actually, it is simply creating an object. I mean providing an implementer class. Later on, you need to define what needs to be written when that particular method is being invoked. So here I'm creating the mock object of the three repositories, order, product, and a customer. Now, once you have the mock order, product, and customer repository, then what you can do is you can create an order service instance. And this order service instance, if you look, it is taking I order, I product, and I customer. Means what? Now, any class that implement I order repository, you can pass here. Any class that implement iProduct repository, you can pass here. Any class that implement iCustomer repository, you can also pass here. And in my order service repository, I am creating a mock repository, which is implementing iOrder repository. Similarly, I create a mock product repository, which is implementing iProduct repository. And same in the case of a customer. So what I need to do, I need to call the object method to retrieve the implementation class. So mock order repo dot object. So this will return me the order repository implementation class. Similarly, in the case of a product and a customer. So with this, our order service repository is ready. So now within the customer, right, within the method, test method, you do not need to create any database object, a context object, nothing. Simply your constructor is ready, which is creating the order service instance, and that order service instance variable, what we defined at the controller level, using that variable, now we can access the method. See, so this is my customer ID. This is my order detail, valid order information. And then what I need to do? Now when I call, right, guys, remember when I'm going to call, then when I'm going to call this order method, right? This method. So internally, it is going to use the customer repository get by ID method. Internally, it is going to use the product repository get by ID method. Internally, it is going to this calculate discount, which is a private method, and again, it is going to call this three method. So what I need to do is now those method implementations we need to define here. Implementations means now when that get by ID customer ID method is invoked, what data to be returned? When that product method is invoked, what data to be returned? See, now when the customer using the customer repository, when this get by ID method is invoked, this is the data that what we need to. Now we are not going to use the actual implementation, the order service when it invoke this get by ID method based on the customer ID. So what implementation we provided here that what it is going to return. So basically it is going to return this customer. Similarly, when it invoke the get by ID method on the product repository, this product object going to be returned. For example, in this case, you can see get by ID method on the product repository. So in this case, when this statement is executed, whatever the logic we are returning from here, that is going to be returned. Similarly, get by ID product repository 20. So here you can see 10 is there, 20 is there. So two method is there. When you pass 10, it will return this. When you pass 20, it will return this one. Now, verifiable method. So what exactly it is? It means right. We are not implementing the actual add method. Means we are not going to add that method to anywhere. So no database involved. So basically, what exactly this verifiable method is going to do? It is going to tell whether this method is being invoked or not. That means here you can see we are setting this add async method. So this add async method, right, it's going to be so basically what exactly this statement means. Now when the operation completed, so this verifiable is going to check whether this add async method is invoked on the order entity or not. So in the order service class, right, you can see there is a add async method which is invoked on the order repository by taking the order entity. So this method is invoked or not within this create order repository method, that is going to be verified by this statement. So basically, it is going to check on the order repository whether the add async method is invoked with the order entity or not. It is what it is going to check. So this statement will tell, we will check later. Once the operation is completed, we will check whether this method is invoked on the order repository or not. How to check that, what we will discuss, right, after some time. So now, once everything is ready, then we need to call the order DTO, create order service method, passing the order DTO. And once we got the result, we need to check whether the result is not null. Customer ID must be same. Order count must be same. And here we set the verifiable. Now you can call the verify method. So this verify method is going to return true if this add async method is being invoked on the order repository by taking the order entity, and how many times? One time. So basically it will ensure if this method is being invoked one time, then this statement is going to return. So this is customer not found method. So basically what I'm telling here, now here I'm using it any in. Means what? Now if you pass any integer value is any in, then in that case it is going to return a null. So basically this it is any means what? Now bypass, if you pass any integer value to this get by ID method on the customer repository, it is going to return null. So if it returns null, that means what? Now I'm passing the order, I'm creating the order DTO, and I'm calling this create order method. And when it calls the create order method, right? In this case, what will happen? Let us try to observe. Now, when I call this method, and here it will check whether the customer exists or not. When this method is invoked, it will come to the implementation part, and then the implementation part we are returning a null. So null means it will throw right this customer not found exception, right? So that customer not found exception, that what we are expecting also same here. So unit test for product not found, same thing. So here, first of all, the customer must be valid customer because first it will check the customer, then it is coming to check the product platform. So what I'm doing here, I'm setting one customer. When the get by ID by customer is being invoked, it will return a new customer instance. And when the get by ID method is called on the product repository by passing any integer value, it is going to return a null object, right? So now, whatever the product ID you pass, whenever it is going to check whether the product ID exists or not, so it is going to return non-object. And again, here I'm expecting not found exception. So now what I'm going to do, I'm going to check the product not found. So first of all, customer must be exist. So I'm returning the customer. Second, product must be exist. I'm returning the product. So here you can see the stock quantity what I'm returning is 1. Now I'm creating the order DTO and I'm specifying the stock quantity 5. So which is less than the, sorry, which is greater than the available stock quantity. That means it is invalid. So in this case, right, when the stock quantity is invalid, then what exception it is going to throw? It is going to throw invalid exception, and that is what we are handling here. Similarly, this is fetching an existing order. For example, this is order ID, this is my order entity, and when this get by order ID method is invoked, so this order information I want to return. So and then right, I'm calling this get by order ID method. So once I call this method, right, if you see, it is calling this get by id method on the order repository, and in the order repository I'm setting, right, when this get by id method is called, I need to return this order object. So that order object is returned, then we are verifying whether the data is valid or. Similarly, missing order, so here you can see I'm specifying one id, and when the get by id method is passed with any integer value, it is always going to return null. So null means in this case order not found. So let us proceed and see whether this is working as expected or not. So what I'm going to do, I'm going to test explorer, and let me first clean the solution. Now I want to check all these mock methods. So you can check one by one, or you can, for example, I want to test. So click on this one. So it will test that independent order. So now I want to test all the services right within this namespace. So what you need to do, right click here and click on the run button. See, now if you want to test all the services within the services folder, you have two options. Either you can click here. So this will test. Other option is there, right? You can also click here. So this will also test all the services. So this is how you can unit test services. And here I have discussed two approaches, how you can use the in-memory, which is not realistic and it is less isolated. I have also discussed another approach called mock, which is the pure isolation. And most of the time, what you need to do, you need to use mock. So that's it for today. If you like this session, then please subscribe to our YouTube channel and don't forget to press the bell icon. In the next session, what we are going to discuss how you can write the unit test code for the controller action method. Thank you. Thank you for watching this session.